So today we're going to talk about, of all the topics that I do in Algebra 2, this actually probably could relate to, like you might use this in the future. Most things that we teach in Algebra 2, you're not going to use, unless you're a high school math teacher. This is one of the things that you could apply in real life, right? So I get kind of excited about that. And it's going to be about interest, right? And there's some terminology, and I want to get all the words out of the way, right? I'm going to use this word called principal, and that's basically what you start with. The amount is what you end up with, right? So what we want are our ending value. Principal is your starting value. We'll have a rate, we'll have time, and just so we understand what everything is, instead of writing amount, I'm going to say A. Instead of writing principal, I'm going to say P. Rate, I'm going to do R, and T, I'm going to use T. Everybody okay with that? And since I have limited board space, I have to erase this part, right? All right, so let's talk about interest for a minute, right? What is interest, right? Well, there's different ways to look at it, but we're going to look at it from a point of view of you put money, you put money in the bank, and it's basically the bank paying you to let them use your money, right? And that's what it is. I mean, like, you wouldn't just randomly put $1,000 in a bank, although that's kind of what we're doing now. You put and what a bank does is it says, okay, you put $1,000 in our bank, you keep it in our bank for a little while. We say thank you very much for letting us use your money, and so we're going to pay you for the use of your money. And how they pay you is something called interest. And what I'm going to do is I'm going to use some numbers that are probably 30 years old, because the interest rates that you currently get at a bank are very depressing. So we're not going to use depressing numbers. We're going to use some numbers that make it look like something actually changes. So when we're going to start with $1,000. So that's our starting value is our principal. So we're going to start with $1,000. My interest rate is going to be 7%, right? And what I'm interested in is how much money can this earn over a given time, right? So we're going to make up a little chart of what first we're going to talk about something called simple interest. And then we'll talk about not simple interest after this. But here's how simple interest works. What we're going to do is we're going to have a chart, and here's my amount. We're going to put that $1,000 in for 1 year. And here's how simple interest works. I'm going to put the $1,000 in on January 1st in the bank. And the bank is going to give me 7% interest. And what's going to happen is that $1,000 stays the same. 1st of January, it's $1,000. June, it's $1,000. October, it's $1,000. On December 31st, the bank says, thank you very much for keeping your $1,000 with you, and we're going to give you 7% of that $1,000. Right? So, if they're going to give you 7% of that $1,000, and how much money are they going to give you? $70, right? In your head, you said, well, they're going to give me 1,000 times 0.07, right? We convert the 7% to that, which equals $70, right? And I need this a little over. I need a little more room. How far can I go? So our time, and here's our amount. So how much money do we have in the bank after 1 year? Are we okay with 1,070? We have our $1,000 plus our interest. So we end up with 1,070. So far, so good. Right? Well, how much money do we have at the end of the second year? Right? All right. So question, is it going to be more, or are we going to earn more or less than $70 next year? More or the less or the same, I guess, should be it. More. Why more?
Because you're taking 7% of the.
You're starting with a bigger number, right? Does everybody see that? If we start with 1,000, we know we're going to get $70, right? Are we starting our second year with 1,000? No, we're starting with 1,070, right? So we should get a little more than 70, right? So how do we find out how much interest the bank is going to pay me my second year? Say it louder.
1,070 times 0.7.
Perfect. All right. So So if I want to find out how much money I have at the end of the, if I want to find out how much money the bank pays me at the end of the second year, is I'm going to do 1,070, and I'm going to multiply that times 0.07. And what do we get?
74.9.
That's 74.9, right? So, hey, we got more money this year, right? We got $4.90 more, didn't we? So then that means how much money do we have at the end of the, how much money do we have in our bank at the end of the second year? $1,144.90. Are we okay with that? Does everybody see what we're doing? Well, that's nice, all right? But my question is, I want to know how much money we have after 10 years. All right? At which point you're thinking, there's got to be a better way, right? I mean, could we find out how much money we have after 10 years? Yeah, we could, right? We've got this little procedure, don't we, right? It's like, okay, we take what we had, right? We add how much money the bank's going to pay us. That gives us a new number. We keep cycling through. So we can keep going through all of these rows until we get to the 10th row, and that would tell us how much money we have. And maybe we could do it for 10 years, but what if we want to do it for 20 years? It's like, oh, there's got to be a better way, right? So let's go back and look exactly how these numbers were computed, all right? So I'm interested in that first number. I want to know where did the 1,070 come from? In that first year, can we agree that 1,070 came from 1,000, which is what we started with, right? Our starting value, plus 1,000 times 0.07? Can everybody agree that that's where that 1,070 came from? Now I'm going to do a little bit of algebra on that. My little bit of algebra is, I'm going to look at this as an expression, and what's in common? I have two terms. What's in common? 1,000, right? So if that 1,000's in common, I'm going to factor that 1,000 out. So if I factor the 1,000 out, let's see what's left inside.
Why are the brackets like that?
Because I'm already using parentheses. So it's just another way of grouping, right? So if I take the 1,000 out of here, that's a placeholder of 1, right? And then I get the plus 0.07, right? Are we okay with that? And so now this is going to be 1,000 times 1.07, because I think we can agree that 1 plus 0.07 is 1.07.
Why is there one?
Well, you have to, when you factor something out, you have to make sure that if you do this times this, you get this, and this times this, you get this. If you don't have a placeholder there, right, then you don't have that term. All right, is everybody okay? And if you multiply 1,000 times 1.07, you will get the 1,070. But I want to write, instead of writing the 1,070, I'm going to write it as 1,000 times 1.07. Is everybody okay with that so far? All right. Well, now I'm interested in, how do I compute how much money we have at the end of the second year? How did I get this number? What did I do?
By the last number, 5.07.
Well, here, wait, I'll color code it. Can we agree that we got this number from 1070 plus 1070 times 0.07? Isn't that how we got this number? Now let's think about where that 1070 came from. That 1070 is this thing, isn't it? And so everywhere I see that 1070, I can write this. And that's what I'm going to do. I'm actually going to write it in brown. So this will be 1,000 times 1.07 plus 1,000 times 1.07. And that's times 0.07. Sorry, I'm working with limited board space. So, what's in common now? I have two terms, this term and this term. What's in common? What can I factor out? Can everybody see that we can factor out the 1,000 times 1.07? So if I pull out that 1,000 times 1.07, what's left inside? 1 plus 0.0. So do you see that? Does everybody see when I pull this out, there's a placeholder?
How come it's a one? Oh, yeah, the one.
Because you do the placeholder, right? And then this is the way I get the 0.07. Well, can we agree that 1.07, 1 plus 0.07 is 1.07?
You need a placeholder?
Yeah, well, if I've got two terms, right?
Yeah,
If I've got two terms up here, I better have two terms in here.
yeah.
Because if I don't have that 1 as the placeholder, then it's going to mess things up. So can we agree that this becomes a 1.07 and a 1.07 and 1,000? Is everybody okay with that? And can we agree that 1.07 times 1.07 is 1.07 squared? So I'm going to rewrite this. And I'm going to rewrite this as 1,000 times 1.07 squared. And my claim is, if you type 1,000 times 1.07 squared, you're going to get the number that would have had there. Now this is huge. See, the reason this is huge is, I bet you have a plan. If I want to find out how much money I have after 10 years, what would you do?
Raise it to the power of 10.
Raise it to the power of 10, right? Can you kind of see that pattern? So if I wanted to know how much money I have after 10 years, that's going to be 1,000 times 1.07 to the 10th. And since I went to the trouble of trying to get a calculator up here, I guess I should turn my calculator on and hit 1,000 times 1.07 to the 10th. And how much money do we have? $19.67 and 15 cents. Wow, almost doubled the money in 10 years. Now, I mean, that's what 7% does, right? Obviously, a lower percent takes a lot longer before you post a double. Did this make sense? All right, that's fine, but now I want a formula, right? And I have a feeling you're going to be able to give me the formula. So remember what I had before? I had some letters before. I had amount is what we want. T is your starting value. R is your rate. T is your time. All right? So we're going to write our formula. Amount equals this. What's the 1,000? It's my initial. So what letter do I use for that? P. What goes in here? Not R, because R is going to be 0.07.
1 plus R.
Are we okay with 1 plus R? Right? Because we got to get the 1.07, so this is going to give us 1 plus R. And what goes for your exponent? T. And this is your simple interest formula. Just curious, have y'all seen that before? Oh.
Yes.
Yeah, okay. I heard Dr. McCoy made you do it.
Oh.
Do you
Oh.
I don't remember.
I do remember that. Yeah.
do you understand where it comes from? I also heard that you may not have understood where it came from.
Yeah, it was like really short.
But does this formula make sense? Do you understand where all the parts come from?
Yes.
Right? Now, so let's look at some things. Here's kind of the significance of this formula. You know, let's say I give you a problem. And, you know, I say this is 1,500 times 1. Let's say this is a problem, right? And if you understand this formula, you can answer a few questions, right? One question. How much money, what's our starting value? 1,500, easy, right? What's the interest rate? 3%. How long are they putting the money in the bank? 12 years. See how we understand how the formula works? Yes?
How do we know it's years and not months or weeks?
As far as my examples today and what I give you tonight, everything is based in years. We are doing interest from kind of the bank perspective where you're putting money into the bank, and I want to make sure we understand that before I start twisting it around. Yes?
So you said A, what did A stand for again?
A is the amount at the, it's what you want, it's the amount at the end.
Oh, okay, so 1,500 there would be,
Your principal is what you started with. Just like we started with $1,000.
okay.
Does everybody see how this works? All right, are we okay with simple interest? Well, the fact that I call it simple interest, there might be some other kind of interest, right? And here's where I get to tell a story. I like telling a story to teach a topic, right? Now, I'm going to preface this whole thing. This is not a true story, right? This is not how, it may have worked out this way. I seriously doubt it, but this is just how I tell the story, right? All right, so, all right, everybody okay where we came up with our simple interest formula? Is it easy to remember knowing where it comes from? Like you all know where all the parts are? Yeah. Okay. So here's our situation. We are going to start with $1,000, and we're still going to have an interest rate of 7%. Okay? And that's how our story starts. And I'm not sure exactly how this was created. Again, I'm making the whole thing up, but so what we're going to say is that the interest rate that banks pay is determined. There's no negotiating that. Every bank has to give the same interest rate, right? And so we have two banks. We have Bank A and we have Bank B. And so if you're trying to pick which bank to go to, it doesn't matter, does it? You have to give the same interest rate, right? Since they're giving the same rate, it doesn't matter. So Bank A hires a mathematician, and what they decided to do to attract people is they say, we're going to give you interest, instead of giving you interest once a year, we're going to give you interest twice a year. Okay? Now, so here's what that means. Like, with simple interest, you put your money January 1st, it stays the same until December 31st, right? And you only get money once a year, right? Well, this new way of doing it, we're going to get money twice a year. So we put our money in January 1st, and at the end of June, we're going to get some of the money, and at the end of December, we get the rest of the money. Does that make sense? So let's think about what that formula looks like. So with n equals 2, we're going to start with 1,000, right? So we start with 1,000, 1 plus. Now let's think about the money we get in June. If we only have our money in for half the year, do we get the full interest rate? Because that interest rate is per year, right? And since I didn't keep it in the full year, how much of the interest should I get? Half. Okay, that makes sense to me. And so I'm going to do 0.07 over 2. Now, that exponent, I called it time in simple interest. Really what this exponent represents is how many times you get money. That's what this exponent represents. It represents how many times you get money. So in 1 year, how many times are we going to get money? 2. Does that make sense?
Could that be a 0.035?
Yes. I'm writing it this way because it's going to lend itself to a formula at the end. Right. So let's see. If I compound twice a year, let's see. So I'm going to type in 1,000 times 1 plus 0.07 divided by 2, and I'm going to raise that because I want to get money twice a year, and I press enter. And remember I guess I should have a little chart of where we left things. So now my chart is going to be when I compounded once a year, I got 1,070. When I compound twice a year, how much money do I have? Okay. So when I compound twice a year, I get 1,071 and 22 cents. Oh, I need to talk about how banks do things. We're dealing with money, so we have to put down the pennies, right? And what do you do with that 5? Banks don't round. They keep it. This is what they do, right? That could be 0.229. They keep it. They don't round up. They don't give you part of the penny. All right? Are we okay? So did we get more money? A little bit, right? Not much, but a little bit. All right? Well, Bank B, not to be outdone by Bank A, says, well, this is called semi-annually because you get it twice a year. So Bank B says, well, we're going to compound quarterly. So how many times are we going to compound? 4, right? And so we're going to do that 4 times a year. What's that going to look like? What are we going to type in our calculator? Same thing, except what? Change the 2's to 4's, right? Change this to a 4 and this to a 4, right? That's going to give us 1,000 times 1 plus 0.07 to the 4 to the 4, right? All right, so type that in and see what we get. I'm going to cheat a little bit. I don't know if you know you can do this. You can scroll up and get your previous answer. Get your previous answer. There you go. And then you can go back here. I'll make that a 4. And make that a 4. And so when n equals 4, so if I compound 4 times a year, that's going to give me 1071.85. Doesn't really care there's a 9 there. Bank's going to keep it. Get a little more money. I mean, obviously not much more. So then Bank A says, well, I'm going to compound monthly. So if I compound monthly, what happens? I make it a 12, right? So now if I make n equals 12, well, that makes that easy. Just change those 2's to 1, make those, change everything to 12. All right, so type that in your calculator and see how much money that gives us. I guess I'll do the same thing. All right, so you can scroll up, get the previous answer. I'll make that a 12. Make that a 12. Yeah. Press enter, and hopefully we get a little bit more money. And so when n equals 12, we get 1,072 and 29 cents. Now, in practice, banks don't compound once a year or twice a year or 4 times a year, even 12 times a year. They compound every day they're open. So what do you think that means they're going to have compounding by? They're not open every day. They're not they're not open on weekends. I mean, some are now, but for as far as banking, think about the stock market. When is it? Like that doesn't run on the weekends, right? Those are banking days. So you cut the weekends out, all those random holidays, right? It ends up being they compound about 240 times a year. All right? So let's compute. What would it be if compounded 240 times a year? So everybody type that in your calculator. And I will too. So I'll make that 240. 240. Probably close that. And so this gives us 1072 and 49 cents.
Mr. Almas,
Yes.
on those equations, I can't really see it, what's the t value?
We're doing for 1 year.
Oh, for one,
Yeah. All of these are 1 year because we're compounding multiple. This is just for 1 year, right? This is if I compound once, twice, 4, 12, or even 240 times.
So would the equation be 1,000 times 1 plus r over n to the power of n?
I'm getting there. Okay.
Wait. Um, the t value would always be 1.
Because you're looking at it and it's like, hey, all right, one I made, it's 1070. If I do once, I get $1.22. If I do it, 4 times, it only goes up like 63 cents. 4 to 12, it goes up, 44 cents. And then here, even to 240, at some point, it's like there's a limit, right? At some point, like even if I did like 300 or 1,000, you're thinking there's probably not going to be that much change. And I'm actually going to talk about that tomorrow. Right? There's something that's going to happen tomorrow. But yeah, I do like that you're noticing, wait a minute, kind of a bigger change here than here, even though I'm compounding more. So hold that thought for about a day, right? All right, so, right, let's come up with a formula, right? So if I were to come up with a formula for this compound interest thing, we need a new variable. Right, so let's recap what we have. The letters we have are A, which is amount, P is principal, R is your rate, T is time, which we haven't really used in this so far, and then N is number of times compounded. How many times you get money per year. So let's see if we can get let's see if we can get a formula out of this. So, A equals, what do we have?
P1 plus r over n.
E plus 1 plus r over n. Does everybody see where that comes from? Now, whatever this exponent is how many times you get money. All right? Okay? So everybody understand that? So whatever the exponent is, how many times you get money. So I'm going to throw out something. If you get money 4 times a year, right? For 10 years, how many times do you get money? 40. Are we okay with 40? How did you get that? 4 times 10. Where 4 was the number of times compounded and 10 was the number of years. Does that make sense? So does it make sense that I'm going to raise this to the nt? Where this exponent represents the number of times you get money. And this so we have our simple interest formula, which was A is equal to P 1 plus R to the T. And then we have, this is called the compound interest formula, which is P times 1 plus R over N to the NT, right? And just so you know, if N equals 1, then you get this first formula. Do you see if N equals 1, then we just get the simple interest one? And this is called compound interest formula. And curious, has anyone seen this before? Does it make sense where all the stuff comes in?
Yes.
Okay. Like my attempt here was, I could just say, here's the formula, use it. The problem with doing that is I don't think you're going to remember it past a week. But if I give you some idea of the logic of how it was created, you got a better shot of remembering it. Yes? Yes, all right. So are we okay with this? All right? So, what kind of problems am I going to make you do? Well, there's 2 types of problems, right? The 2 types of problems that I can ask are, like one is, let's say you invest $2,500 at 5.25%, compounded quarterly for 8 years. Right? Yeah, how much money do you have if you invest $2,500 at 5.25% compounded quarterly for 8 years? And so how would you figure that out? Well, what do you start with? How much? What's your initial value? 2,500. If you're compounding quarterly, what's going to go in here? So 1 plus, are we okay this interest rate is going to be 0.0525? Because whatever your percentage, you got to move it over. If you're compounding quarterly, you got to divide it by 4. And what's your exponent? 32. And you got that by doing 4 times 8, right? Everybody see how that works? So we started with, we're just using our formulas. Tells us what we start with. It's 1 plus whatever your rate divided by how many times you compounded. And you want to make sure whatever this exponent is how many times you get money. So everybody type that in. Then we're going to start with 2,500. And we're going to do 1 plus 0.0525 divided by 4 raised to the, you could say 4 times 2, or you could just say 32. And so how much did we get? Okay. Does everybody see how that worked? Are we okay using that formula? So this is, if I tell you your starting value, I tell you the interest rate, I tell you how many times it's compounded, and just so you know, the words they use are semi-annually, so we know twice a year, quarterly, 4 times a year, monthly, 12 times a year. That's pretty much it. All right? And it's just practice. Can you plug in? So there's 2 types of problems. This is one type where you just plug in the formula. The other type of problem is what if we want $2,500? Do you see the difference? If you start with 2,500, that means you get to put the 2,500 here, right? If you want 2,500, where do you have to put it? I have to put it in for the A. And so if I plug that in for the A, that's going to give us 2,500 equals P times, because we're looking at 1 plus 0.0525 over 4 to the 32. Do you see the difference? If you start with a certain value, you get to plug it here, right? If you want a certain value, you have to plug it here. Now, you might think, okay, this is hard. How do you solve that? Well, guess what happens if you plug 1 plus 0.0525 divided by 4 to the 32? When you type that in your calculator, are you going to get a number? And so you have a number equals P times a number, right? How do you get P by itself? Divide by whatever that number is, right? Does that make sense? So if I want to divide by whatever that number is, I'm going to cheat a little bit. I think I can do this. Wait. Hit divide. There we go. See how I did the 2,500 divided by that thing? And so I needed to, if I want to make sure that I have $2,500 at the end of 8 years, I need to put in $1,647.11. Does that kind of make sense? Yes, no? All right. So here's what we're doing.